Recording in progress. Hello everyone. In this video, we're going to be doing some examples of finding asymptotes, domain, range, and end behavior for exponential functions. So let's start with this first example here, and we are going to find the horizontal asymptote first. So the horizontal asymptote. And the horizontal asymptote for an exponential function is going to be y equals k. So it's going to be y equals the k value, which is just going to be the number on the very end. So our k value is the number on the end, which is minus 5. So the horizontal asymptote is going to be at y equals negative 5. All right, now we're going to do our domain and range. Okay. So domain, remember the domain for all exponentials is going to be negative infinity to positive infinity. And now we're going to do our range. Okay, and with the range, what you should find is that the asymptote is actually included in the range. So it's going to be using this minus 5 here, but I want to see, is this from negative infinity to negative 5, or is it from negative 5 to positive infinity? So let's go look at Desmos, and we're going to type this guy in. All right, so we have 2 times 3. Oops, that's a 2, not a 3. 2 times 3 to the power of x, and then all minus 5. Okay, and what you'll see here is that this function does not exist down in negative infinity. If I go down here, I do not see the function at all. But the function does start existing on the y-axis, so looking at the y values, here at negative 5. So this is the part of the range that we're going to be using. So from negative 5 until positive infinity, because this function does exist up here in positive infinity looking at the y-axis. All right, so the range is going to be from negative 5 until positive infinity. Because negative 5 is an asymptote, it cannot equal that value. So we're just going to put parentheses, negative 5 to positive infinity. Okay, now we're going to do our end behavior. And for exponentials, it is going to be from as x goes to negative infinity, y goes to something. As x goes to positive infinity, y goes to something. So as x goes to negative infinity, y goes to something. As x goes to positive infinity, y goes to something. And the reason this is because we do have a domain of negative infinity to positive infinity, and domain are x values. So if we're looking at the left-hand side, which is this first one here, and I'm just going to make a little note. This is the left-hand side, and this is the right. So if I'm looking at the left-hand side of my equation here, you can see that this is just leveling out right here at negative 5. So it is approaching that asymptote, and that's exactly what you should see. It's going closer and closer to negative 5. So if you look at the y values here, it is getting so close to negative 5 that Desmos is saying this is negative 5. But it's actually not. It's really, really, really close to negative 5. All right, so on the left-hand side, it's getting closer to negative 5. And then if we look on the right-hand side of this graph, we can see that this is just pointing straight up to positive infinity. So it's going up to positive infinity. That means that this one is going to go to positive infinity. All right, and then the last thing that I want to say is this always increasing or always decreasing? And this one we can see is always going straight up. So if you're on this roller coaster, it'd be a pretty scary ride, just be going straight up the entire time. So this is going to be always increasing because you can see it's always, if you're on a roller coaster, you'd always be going straight up. Okay, so let's try out another problem. All right, and this is another exponential, so we are going to have the same features going on. So I'm just going to start writing HA for horizontal asymptote. We're going to be finding the domain, we're going to find the range, and we are going to do the end behavior. Okay, so with the domain, I can go ahead and say that's negative infinity to positive infinity. With the range, I'm not really sure about that yet. For the end behavior, I can go ahead and write as x goes to negative infinity, y goes to something. As x goes to positive infinity, y goes to something. All right, so for the horizontal asymptote, remember that's going to be y equals the number on the end, that k value. So this is going to be y equals negative 4. Y equals negative 4. All right, we know that the range is going to include negative 4, and so is the end behavior. So let's go see if it's going to be -4 to positive infinity or negative infinity to -4. All right, so we're going to type this guy in. 1/2 to the power of x, and then -4. All right, and whenever I look at this, this function does not exist down in negative infinity. I do not see it down here at all. It starts existing right here at the horizontal asymptote. So you can see that it starts right here, which is down around -4. So it's starting at -4, and then it does exist up in positive infinity. Remember, we're only looking at the y-axis for the range. So from -4 until positive infinity. Okay, now for the end behavior, we want to look at what's happening on the left side and then what is happening on the right side. So this is the left and this is the right. So let's go look at the left-hand side first. And we can see in the left-hand side, this is going straight up to positive infinity. If I look at the left, it's going all the way up. It's pointing at the sky. So on the left-hand side, it's going to be going to positive infinity. And on the right-hand side, hopefully you've been realizing that we're using this number on the end a lot, here, here, and here. And it's also going to go here on our range. So this is going to be to -4. All right, and you can see this over here as well. You're using -5 in the horizontal asymptote, the range, and the end behavior there. All right, so let's try out another problem. We're just going to do 2 more, and then we're going to move on to our logarithms. Oh, and I did want to say whether this was always increasing or always decreasing. And you can see that if you're on a roller coaster going from left to right, you would just be going straight down, and you would start leveling out over here. So going straight down and then starting to level out, but you're actually still decreasing. So this is going to always be decreasing. Okay, let's try out 2 more, and then like I said, we'll move on to the logarithms. And for each of these, we're going to be finding the horizontal asymptote, the domain, the range, and the end behavior. Don't forget, we can go ahead and write out our domain. We can go ahead and write out y equals. We can write out as x goes to negative infinity, y goes to something. As x goes to positive infinity, y goes to something. So for our horizontal asymptote, we're going to be using +4 because that is the number that's being added on the end. That's the constant term. So it's going to be y equals 4 here. And we need to see if this range is going from negative infinity to +4 or from +4 to positive infinity. So let's go type this in. -2 times 1/2 to the power of x plus 4. All right, in this one, you can see it does exist down in negative infinity. So it's from negative infinity all the way up until +4. And you can see that the y values are going to +4 here. This function does not exist up in positive infinity. It exists from negative infinity up until +4. So we're going to go negative infinity to +4. Okay, now let's look at our end behavior. And remember that the first one is going to be our left side, and the second one is going to be our right side. So let's look at the left side first. And we can see that in the left side, this is just going straight down towards negative infinity. It's pointing straight down to the ground. So this is going to be going to negative infinity on the left. And you can probably guess what it's going to on the right. It's going to be using our asymptote. So on the right-hand side, you can see the y values are leveling out at 4. So this is going to be going towards 4. All right, and this function is either always increasing or always decreasing. If you're on a roller coaster, you'd be going straight up, and then you kind of start leveling out, but you're actually still increasing there. So this would be always increasing for that. Always increasing. Okay, and we're going to look at one last example before we move on to the logarithms. All right, so let's look at this very last one. And we are going to be finding the same things, the horizontal asymptote, the domain, the range, and the end behavior. And we can go ahead and write out a couple things. Okay, so with our first thing, our horizontal asymptote, there's actually no number that is being added on the end. So that kind of confuses a lot of people. A lot of people like to say it's -3, but what is really happening is that there is a +0 on the end. So this is going to have a horizontal asymptote of 0, and we now need to see how the 0 is going to be incorporated in the range. So let's go type this function in, -3 to the power of x, and you can see that this function does exist down in -infinity, and it does not exist in positive infinity. So this is going to be from -infinity all the way up to our asymptote, which is at 0. So -infinity to 0. And with our end behavior, we need to see what is happening on the left side and what is happening on the right. So here's the left, here's the right. Let's go look at the left right now. So on the left side, you can see this is going towards 0. So the left side is going to go to 0. And the right side, if we look at that, this is just pointing straight down towards the ground. So this is going down towards -infinity. Okay, and we do need to see whether it's always increasing or always decreasing. If I was on a roller coaster and I started this way, I would just be going straight down towards the ground. That'd be a very terrifying roller coaster. This would be always decreasing. Okay, I hope that you guys enjoyed this video. Please stay tuned for the next video where we're going to do the exact same thing, but with logarithms. And you will see that everything is just in reverse of what we just did. Okay, have a great rest of your day. Goodbye.